Okay, intermediate algebra, the last chapter that we have, starts with evaluating roots. This entire chapter is about square roots, square root equations, how to evaluate and simplify square roots. So we'll start with just evaluating. So generally speaking, a square root, a number b is the square root of a if b squared equals a. So what's the square root of 81? It's 9 because 9 squared equals 81. One thing to note is that squaring usually cancels out the square root, which will be useful for equations later. Generally, the principal square root is the positive. That means if you see the square root of 121, even though negative 11 squared and positive 11 squared are both 121, you'll always take the positive. When this changes is you end up with an equation, x squared equals 121. When you introduce the square root, then a plus or minus comes into play, and we'll talk about that more later. So let's just talk about evaluating these. The square root of 121 is 11, because 11 squared is 121. If you have a fraction, you take the square root of the numerator and the square root of the denominator, so there's a negative out front. The square root of 64 is 8. The square root of 169 is 13, so the square root overall is negative 8/13. The square root of 0.49, this is really 49 over 100, because that's the hundredths place. So this is 7/10. We can turn this back into a decimal like 0.7. If we think about it, 0.7 squared, we'll have two numbers behind the decimal place, and 7 times 7 is 49. So there are a few ways to do it. You may know naturally that 0.49, the square root of that is 0.7. One thing to note is that the square root of a decimal between 0 and 1 actually gets bigger than it was as a square root. Now, anything that's not a perfect square under the radical is said to have an irrational square root. If there's a negative number under the radical, it has no real square root. Squaring a square root expression will cancel out the square root. So find the square of the following. The square root of 1/3 squared is just 1/3. The negative square root of 99 squared is 99. Because the negative times negative is positive. Even the square root of this algebra thing, if I squared it, the square root and square root, again, they're inverse operations, they cancel. 9y squared plus 6. It's true that in order for them to be actual inverses, you have to kind of mess with it a little bit domain-wise, but they're just generally inverses. Estimating irrational roots. To estimate a root that's not a perfect root, you can estimate it by figuring out what perfect roots it's between. For example, on the next page, the square root of 7. What do we know about the square root of 7 is between the square root of 4 and the square root of 9, which are perfect squares. So it's somewhere between 2 and 3. So we say it's between 2 and 3. Because this is between those two perfect square roots. Square root of negative 9, square root of 93 is between... Technically, it's between the square root of negative square root of 81 and the negative square root of 100, which is negative 10 and negative 9. So this is between negative 10 and negative 9. Square root of 237 may be out of your wheelhouse, but it's greater than 225, but less than 256. Which is actually 15 and 16. So between 15 and 16. So some applications, the Pythagorean theorem, a squared plus b squared equals c squared, using this to our advantage. Find the length of the shortest side of a triangle when the longest side is 10 inches, the second longest side is 8 inches. This only works for right triangles, by the way. But this is a right triangle. We have 8 and 10. The long side is called the hypotenuse. This is our unknown. So our unknown squared plus 8 squared equals 10 squared. So x squared plus 64 is 100. Subtract the 64, you get x squared is 36. We know that means x is technically plus or minus 6. Now it's talking about the length of the side of the triangle, so we know that it has to be positive. because it's a length. The kite string is 25 feet long. Horizontally, the kite is 7 feet away. So we got person holding a kite. It's 25 feet long. Said horizontally, this is 7 feet away. How high in the air is it? Again, this is our C, it's on the long side. This is a right triangle. So 7 squared plus our unknown squared is 25 squared. Which means 49 plus x squared is 625. So x squared is 576, which is 24. Now again, it's a length, so it has to be positive 24, which means that's a word problem. We should have a word answer. The kite is 24 feet in the air. We could argue the same thing for up here, the short side of the triangle. Is 6 inches. Nth root. So we know the square root is because something has to be squared. 9 squared is 81. But we have more roots than that. Let's say we had the third root, then the number multiplied by itself 3 times would have to be the number. Fourth root, 4 times, etc. So the cubed root of 27, I need a number that multiplies by itself 3 times to get 27 to have a cube root. So the cube root of 27 is 3 times 3 times 3, so the answer is 3. The negative cubed root of 1,000, so 1,000 is 10 times 10 times 10, so this is negative 10. The negative cube root of negative 64. So unlike square roots, for square roots we couldn't have negative under the radical, because any negative number squared became positive. For odd roots, that's not the case. I can have a negative number under the radical for odd roots. Negative 64 is really negative 4 times negative 4 times negative 4. So this whole thing is negative 4, which is just 4. Generally speaking, if you have a negative in an odd root, you could have just pulled it out front, and the negative times negative would have become positive, and the cube root of positive 64 would have just been 4, like we just found. That's all for 10.1. Next video will be 10.2.